Space is big, really big. It's so vast that it's almost beyond human comprehension. When we try to grasp the enormity of space, our minds struggle to fathom the sheer scale of it all. When we look up at the night sky, we see countless stars scattered across the darkness. Each tiny dot of light represents a star, a distant sun shining brightly in the vast expanse of the cosmos. Each one of those stars is a sun, often with its own planets orbiting around it. These planets, known as exoplanets, come in all shapes and sizes, some potentially harboring conditions suitable for life. And that's just our galaxy, the Milky Way. Our home galaxy is a sprawling collection of stars, planets, and cosmic dust, all bound together by gravity. There are billions upon billions of galaxies out there, each containing billions of stars. These galaxies come in various shapes and sizes, from spiral galaxies like our Milky Way to elliptical and irregular galaxies. It's mind-boggling to think about. The sheer number of stars and galaxies is overwhelming, and it makes us realize just how small we are in the grand scheme of the universe. The universe is full of mysteries that we are only just beginning to unravel. From the birth of stars and nebulae to the enigmatic nature of black holes, there is so much we have yet to understand. Every new discovery leads to more questions and pushes the boundaries of our understanding. Scientists and astronomers work tirelessly, analyzing data and exploring the cosmos to uncover its secrets. It's a journey of endless exploration, and it's one that we're all on together. Whether through manned missions or robotic probes, humanity continues to reach further into the unknown. We have so much to learn about the universe, and that's what makes it so exciting. The more we discover, the more we realize how much there is still to uncover. So, buckle up and get ready for a cosmic adventure. The journey through space is filled with wonders and surprises, and it's a voyage that promises to expand our horizons. We're about to dive into some of the most mind-bending facts about the universe, exploring everything from the expanding cosmos to the possibility of parallel worlds. The idea that our universe might be just one of many is both thrilling and perplexing. Get ready to have your mind blown. The universe is a place of infinite wonder, and as we embark on this journey, we'll encounter phenomena that challenge our understanding and ignite our imagination. Imagine a balloon with dots drawn all over it. Each dot represents a galaxy, a star, or even a planet in the vast expanse of the universe. Now, imagine blowing up that balloon. As you blow air into it, the balloon starts to expand. What happens to the dots? They all move further away from each other as the balloon expands, right? This is a simple yet powerful analogy to understand the expansion of our universe. The universe is kind of like that balloon. It's constantly expanding, pushing everything further and further apart. Every galaxy, every star, and every planet is moving away from each other. But here's the kicker. The universe isn't just expanding, it's accelerating. This means that the rate at which the universe is expanding is increasing over time. It's like something is pushing on the gas pedal, making the expansion go faster and faster. Imagine driving a car and continuously pressing down on the accelerator. The car speeds up more and more. Scientists call the mysterious force driving this acceleration dark energy, but they're still trying to figure out exactly what it is. Dark energy makes up about 68% of the universe, yet it remains one of the biggest mysteries in cosmology. This runaway expansion has some pretty wild implications. It affects not just the distant future of the universe, but also our understanding of fundamental physics. For starters, it means that the most distant galaxies are moving away from us faster than the speed of light. This might sound impossible, but it's a consequence of the expanding space. Don't worry though. Nothing can actually travel through space faster than light. The speed of light remains the ultimate speed limit in the universe. It's just that the space itself is expanding, carrying the galaxies along with it. Imagine dots on a rubber band being stretched. The dots themselves aren't moving, but the space between them is increasing. This concept of an expanding universe started with the Big Bang, the colossal explosion that created the universe around 13.8 billion years ago. Since then, the universe has been growing, evolving, and expanding. Evidence for this expansion comes from the cosmic microwave background radiation, The afterglow of the Big Bang, which shows us a snapshot of the early universe. Modern telescopes and space observatories continue to study this expansion, providing us with more data and helping us understand the nature of dark energy and the fate of the universe. As the universe continues to expand, galaxies will move further apart, and the universe will become more isolated. This runaway expansion could lead to a future where galaxies are so far apart that they become invisible to each other. The ultimate fate of the universe is still a topic of much debate. Will it end in a big freeze, where everything becomes cold and dark? Or a big rip, where the expansion tears everything apart? Or perhaps a big crunch, where the universe collapses back in on itself? Only time will tell. For now, we can only marvel at the vastness and mystery of the cosmos, and continue to explore and understand the runaway universe we call home. Space might be full of stars and galaxies, but it's also full of nothingness. And we're not just talking about the empty space between planets. Scattered throughout the universe are gigantic regions called voids, which are almost completely devoid of galaxies. One of the most famous of these cosmic deserts is the Boötes void, named after the constellation it's located in. This colossal void is about 330 million light-years across. To put that in perspective, if the Milky Way galaxy were a basketball, the Boötes void would be the size of the entire Earth. The sheer emptiness of the Boötes void is both fascinating and a little unsettling. It's a stark reminder of the vastness and mystery of the universe we live in. Scientists are still trying to understand how these voids formed and what their existence tells us about the evolution of the cosmos. Black holes are some of the most extreme and mysterious objects in the universe. These enigmatic entities have fascinated scientists and astronomers for decades, pushing the boundaries of our understanding of physics and the cosmos. They are regions of space-time where gravity is so strong that nothing, not even light, can escape. This phenomenon is known as the event horizon, the point of no return. Once something crosses this boundary, it is lost to the black hole forever. These cosmic monsters are formed when massive stars collapse at the end of their lives. When a star exhausts its nuclear fuel, it can no longer support itself against the force of gravity, leading to a catastrophic collapse. This collapse compresses the star's core to an incredibly small and dense point, creating a black hole. Imagine squeezing the entire mass of the Earth into a tiny ball the size of a marble. The density would be unimaginable, and this is precisely how dense a black hole is. The gravitational pull of such an object is so intense that it warps the very fabric of space-time around it. That's how dense a black hole is. The concept of such density is almost beyond human comprehension, yet it is a fundamental aspect of these celestial phenomena. Anything that gets too close to a black hole gets sucked in by its immense gravity and is never seen again. This includes stars, planets, and even light itself. The process of being pulled into a black hole is known as spaghettification, where objects are stretched and torn apart due to the extreme gravitational forces. But black holes aren't just cosmic vacuum cleaners. They are much more complex and dynamic than that. They can also be incredibly powerful engines, driving some of the most energetic processes in the universe. They can also be incredibly powerful engines. When matter falls into a black hole, it doesn't just disappear. Instead, it forms an accretion disk around the black hole, where it is heated to extreme temperatures and emits intense radiation. As matter falls into a black hole, it heats up and emits intense radiation, creating some of the brightest objects in the universe, quasars. These quasars are so luminous that they can outshine entire galaxies, making them visible from billions of light-years away. These cosmic lighthouses shine brighter than entire galaxies and can be seen from billions of light-years away. Quasars serve as beacons, helping astronomers study the distant universe and understand the early stages of cosmic evolution. The study of black holes and their incredible properties continues to be a frontier of scientific research, revealing the awe-inspiring power and mystery of our universe.